Hello, everybody. How are you doing? It's me, Murat Sultan Ezouidi, the pioneerism method. Before I faced a technical problem, but we solved this problem and we repaired. In fact, I let's say call my friend Ahmed, okay, to repair this problem, and he did by phone. Hello, Mr. Ahmed. How are you doing? Now I'm live, my brother Ahmed Mahmoudi, okay, and thank you for repairing and solving the problem that I faced. Okay, thank you. Thank you. Okay, so we continue with all that. This is the Pioneer Smart Sultan video. Welcome again. Welcome everyone to this special session. Today we will not just solving problem, we are challenging mathematical history. According to Abel theorem, general solution for 5 degrees or and higher are impossible within gravity. The door was closed. Mathematicians started searching, but Professor Murat Fakhrizadeh says otherwise. Here, through the power of the Ezouidi theorem, a new path is revealed on that leads us beyond classical limits into the exact algebraic solution of even 11th-degree polynomial equation. So here today I will demonstrate this, not with approximations, not with guesswork, but with precise exactness. Okay? As Abel before said, now Mr. Martin opened the door and says, yes, it is. So let's now demonstrate and find the 11th degree polynomial equations. Okay, that we will apply the theorem of Murat Sultan. Okay, so here, as you see, my colleagues. Okay, this is the polynomial to the power 11. Okay, this is our 11th degree polynomial equation. Question 7, I thought, example 7. Okay, example. Example 7. Okay. Here. Now example 7 like that. So I will now start sharing this screen with you, professors, colleagues, and teachers and students. So that will be benefited from from the the lecture. So now let me guide you through the lens of Ezouidi or Ezouidi theorem, where structure and symmetry lead the way. This is, in fact, is not trial and error. This is systematic or systematic. This is exact and this is reproducible. So I will just share now the screen record. Okay, okay, example 7 is now possible. Example 7. Example 7, this is example 4, let's reach example 7, just a moment, okay, okay, 6, this is 6. So prepare yourself, this is the pioneers in math, your brother Murad Sultan is here to help you apply this structure, this method that leads you with exactness. Okay, with through algebraic proof. Okay, let's continue. Okay, this example we did it, we solved it. Okay, not this, we don't like it. Okay, go down. Hello, Habib. How are you? How are you doing? It's me. Right. Okay, correct. We can select. Okay. I will be live. I was live now. Okay. Okay, I will share now the screen, my professors, to let you join the lecture and see what happens. Exactly. Okay. We share the lecture. Now we can view. So this is the lecture, my learners. Okay. And we will solve this level differential equation using Murad's method. Okay, using the theorem of Murad Sultan Ezouidi method. Okay, so as you see, I already shared, let's say, the lecture with you, and you will see that here it is not guessed, not approximated, but exact as it is. Okay, and we will touch, okay, and smell and listen, okay, the exactness, the exactness. Okay, so here I'll go down now. You can see now the structure. You can see the whole lecture. Okay, okay, shown here. For example, 7, isn't it? Example 7. We'll wait. Example number 7. Okay, here it's 9. Okay, now it's 10. And then we make our okay. S11 make us 10S means very 11. Now my learners is that this is our 11 degree communicator. This one. Okay. You can see this one. This is our 11 degree equation that can be written as x to the power 11 minus x to the power 10 plus 55 divided by 11 square x to the power 9 minus 165 divided by 11 to the times x to the power plus 330 11 to the power 4 times x to the power 7 minus 461 divided by 11 to the power 5 times x to the power 6 plus 436 divided by 11 raised to the power 6 times x raised to the power 5 minus 315 divided by 11 raised to the power 7 x raised to the power 4 plus 155 divided by 11 raised to the power 8 x cubed minus 40 divided by 11 raised to the power 9 times x squared minus 1 over 11 raised to the power 10 times x plus 6 over 11 raised to the power 11 equal to 0. So here you can see this one, it's an 11 degree Coulomb equation. Okay, so we will go step by step to solve this 11 degree Coulomb equation using Murad sometimes we fail. Meaning you are going to dive into the structure and let's derive s minus 1 and s1 and s0, s2, s3, s4. Okay, so here my colleagues, okay, this is you can see that this is in fact is going to the power 11. These are the coefficients of my original 11-degree from the equation. Now I'm going to dive into the structure and replace k with 0. I will obtain s minus 1, which is by convention is equal to 1. Okay, I will continue to find, let's say, S1. Let's dive into the structure and put k to 1 to obtain S0. This is S0 in the last, let's say, the formula will give you the sum of the x roots of this new degree to the equation, which in fact is equal to an error, okay, equal to 0. So here you can see that this is S0 is equal to negative combination 11 choose 1 times 1 plus 11 times 1 is equal to negative 11 plus 11. It will be 0. So for k equal to, just go and dive into the structure and we will see one by one the exact value of the s subscript k minus 1. Okay, here my learners, my professors, it's very easy, just a direct application. Uh, you will see the S0, okay, S0 equal to NL. Now I'm going to dive into this structure and put in case of 2 to obtain S1. S1 has to be equal to negative combination and 2, 3, n is 11 times 0.2 squared, and 0 is going to be 1, okay, and the 1 is going to be 55 divided by 11 raised to the power 3. So the value of the S1 in fact is going to be equal to an L in this example, means the value of, let's say, the value of S1 is going to be equal to 0. Now we continue. We should, let's say, uh, substitute k equal 3 to find let's say, S2. Okay, this is S2. You see it. Okay, in the formula or in this structure, in the theorem of Rossiter-Ezouidi, put k equal 3 to get S2. This S2 is been written in its lowest term. Okay, and the value of S2 here, you can see sample and sample calculation, can use a calculator, and then this one, my learners, has to be equal to another. Okay, now let's and find the value of S3. To find S3, just substitute or set k equal 4 in the decimal formula of vertical GD, and you make your other substitution. This is the formula that will give you the value of S3. So that substitution, so this one has to be equal to 0. We continue, my professors. We went in fact to find S, S5. Find S4, sorry. Find S4 here. We should get rid of the unusual methods and the classical method that uh, uh, that let's say that fail, okay, and concentrate or let's say focus on the Ezouidi method, and we will see that S4 here is gonna be equal to, okay, is equal to minus 1. Okay. Means we got s minus 1 equal 1, s0 equal 0, s1 equal 0, s2 equal 0, s3 equal 0, but s4 is different. Means that, what does this mean? Means that if you are going to dive into the structure, every term skips, okay, and every coefficient, the method, okay, knows how to listen. Okay, so here we found exactly the value of s3, which is equal to 0. We continue my learners I want to find S4. Here, just we are going to focus on this formula, okay, and make your own substitution, and you will see that this one in fact is going to be equal to minus 1. S4 is a minus 1. Now we continue to find, let's say, S5, just get inside to see the structure of the applied reading method. When k equals 6, you find that S5 is equal to 0 after making substitution in this formula. Okay, we dive again into the structure. Okay, this is the theorem of the Professor Washington Ezouidi, and we'll set k equals 7 so that you can obtain S S6. So S6 here is given by the formula, by this formula 1k equals 7. So this one, my goodness, is in fact equal to another. So you have time to check this one, okay, to make the calculation, and you will figure out that the value of 6 here is equal to 0. Let's dive in again, my professors, learners, and teachers, and colleagues to find the value of the S7. To find the value of S7, it's very possible. Here it is, okay. Uh, Here it is the structure, and you will put k equal 8. As we put k equal 8 here, my professors, you will see that S, S7 is equal to the general formula, and you will make your own substitution. Okay, you need only the first coefficient up to N7, okay, because this formula index is 7. So here is going to be equal to 0. Now I'm going to find the ninth coefficient. To find the ninth coefficient, you have to put k equal 9 in the Ezouidi theorem. And after that, okay, after that, my learners, it's very easy. After that, you will just uh, write the formula in its those terms and make the substitution, okay, to find the value of S8. Now we calculate S8, we will find that it will fact equal to an L, okay? So, as we say, we said before, the S minus 1 is different really by convention, okay? And S1, S0, S3, S5, S6, S7, and S8 are all different, are all equal to 0, except S4, which is equal to minus 1. So if we continue now, we see that S9 is going to be equal when putting k equal 10 in the discount formula, in the theorem of what you can do. Okay, so we see that S9 in fact is going to be equal to S9 is going to be equal to minus 6, okay, is equal to minus 6, less coefficient of this, the minus 6, okay. So we calculate all of this, from this to that, it will be, uh, uh, from this to that, it will be negative 5, okay. So, of course, multiply by 11 raised to the power 10, divide by 11 to the power 10 equals to that. So therefore, we continue. Now we reach S9 is equal negative 9, negative 6, mean is different to 0. So to find the 11 coefficient here, if the 11 coefficient is going to be equal to 0, it means that we will get the first two. Means we are going to go back to the make that transformation and make alpha subscript k equal L042 plus 0 divided by 11, because the square of new resolution equation is going to be equal to another. So here, after calculating this, my professors, my teachers, you will see that the value of S10 is going to be equal to another. Okay, we proceed. So here in this example, you will see that there is no guesswork. Okay, you will see it exactness. Okay, and you see this one, the value of S10, you use this formula, the value of S10 is going to be equal to 0. Now I'm going to write my 11 degree conjugate equation, which is new, that corresponds to the original one. So p of x has to be equal like that. X raised to the power 10 minus 0.2 x raised to the power 10 up to negative S10 of 42. S10 is equal to 0. S9 different to 0. S0, S8 equal 0. S7 equal 0. S6 equal 0. S5 equal 0. S4 now it's different to 0. It's different to 0. Okay. Later it's different to 0. S0 equal 0. S1, S2, S3, and S minus 1 is different to. And here we'll obtain, let's say, uh, polynomial to the power 11 can be written as x to the power 11 minus s4 x to the power 6 plus s9 for s9 42 times x equals 0 means what, my friend? So means that x has to be equal to 0 or x to the power 10 minus s4 42 x raised to the power 5 plus s minus 42 equals 0. Here in this step, I'm going to apply my discriminant formula 1 k equal to, meaning that I'm going to suppose that x raised to the power 5 equals capital X. So I will obtain capital X raised to squared minus what? Minus this one, I mean. Okay, so it will be x raised to the power 2 x raised to the power 5 all raised to the power 2 minus s4 for the x raised to the power 5 all raised to the power 1 plus s9 equal 0. So my decimal formula 1 n equal to has to be written as that minus s4 squared plus 4 times s9. So this implies that s1 upon 2 dash is equal to negative 1 square, which is negative 1, plus 4 times negative 6 will be negative 45, 4, 34. So this one, the sum of S1 of 42 dash is negative 25. Therefore, minus S1 of 42 dash is 25. It's 5 squared. Now I'm going to write x raised to the 5 as that, S4 plus negative S1 of 42, or divided by 2. Therefore, this one can be expressed like that. The first five roots are this polynomial to the power k. Okay, not the original level. These are the polynomial. The five roots of these okay, of these 10th degree from the equation. So it will be, now I'll make substitution. It will be minus 1 plus negative 5 divided by 2. Okay, divided by 2. Therefore, minus 1 plus 5 is 4. Divided by 2, it will be 2. Okay, like that makes sense. Like here. So, become 25, the square 25 is 5. I wrote 2. Minus 1 plus 5 is 4. Divided by 2 will be 2. So, the first 5 x roots of this many to the power 11, this one represented in terms of a subscript k minus 1. So, it will be in fact 2 raised to the power 5 exponential 2ik pi divided by 5. Then the second five exact x roots of this polynomial to the power 11 are minus 1, it will be, of course, will be minus 5 because the first is positive. So minus 1 minus 5 divided by 2 will be minus. Divided by 2 will be negative. Negative 3, this minus I will write as exponential I5 divided by 5. So this one could be 3 raised to the power 5 exponential 2k plus 1 I5 divided by 5. So here I got the 11th exact x roots of these polynomial to the power 11. Now to find exact the 11th exact roots of my 11 my original degree from the equation that I started with, okay, you are going to use, let's say, go back to the x transformation, we make a 0 for the q plus x substitute from 0 to 4. Okay, I will get this one, okay, to 4. So, just direct application, my learners, you will see that L0 is 1, okay, is 9, okay, is 9. So, L0 in fact is going to be 1 plus this, okay, plus 2 raised to the power 5 exponential 2i equal 5 divided by 5. All divided by 11 because by power is 11. These, when k equals 0, just replace them. K equal 1, 2 up to 2. The first root, which are exact, okay? This is 4, not 9. From 0 to what? From 0 to 4, not from 0 to 9. I'll correct this. Okay, from 0 to 9 is 9. So here, you can see that this is not just about one equation by the study. This is about changing how we understand algebra. So Ezouidi method rewrites what was believed to be a dead end. We, we bring, we, let's say, we bring light into what was once shadow. So the method is not, this method is not only powerful, but it's a new chapter in the study of mathematics. It's a new chapter in the study of mastering, looking up and getting from the equation. So here my learners, uh, and so one by one the exact roots of this 11 people equation stands before us. Okay, where others so all we are or had we have covered doorway. Therefore, these are the roots of my five roots of my original division equation. Then you remember when x equals 0 is 1, means that alpha 11 is equal 1 plus 1 divided by 11, so it will be 1 over 11. So these are the exact roots of my division equation. So thank you for listening and goodbye. This is the pioneers, Mr. Mark, that is really great, great you wherever you are. Okay? Thank you for listening and goodbye. Okay, I will stop sharing first. Okay. So as we told, we can see that. Okay, we can say that. Thank you for joining, and remember, mathematics still holds seconds, but we now hold the key. Thank you for listening, and goodbye. Okay, thank you, my learners. I will close everything now. Okay, from next week, inshallah, I'm going to solve 12 related equation. Okay, so wait for me till I will be live. Okay, thank you and goodbye.